So let us discuss about the units of order of a reaction. Let us consider a general equation that is A of A plus B of B gives C of C plus D of D. If you write the rate equation for this reaction, rate is equal to rate constant into concentration of the reactants raised to a power. Right? Concentration of the reactant raised to its power. Right. So we are going to find out the units of rate constant. Right. We are going to find out the units of rate constant. So let us take the rate constant here. K is equal to rate by concentration of the reactant. Some rate concentration of the reaction raised to its power. Okay. Now, what is rate? What is rate? Rate is nothing but change in concentration. Change in concentration. Change in concentration with respect to time. Am I right? With respect to time. So this is the rate. So let me write the rate as this one. The rate is concentration with respect to time. Am I right? So this rate term alone, I can write concentration with respect to time. Right. That into, already the concentration terms are the denominator. So that let me write 1 by concentration. 1 by concentration. Right. This is the formula to calculate the unit of the rate constant, right? Unit of a rate constant, right? We know that there are zero order, first order and second order reaction. If the order of the reaction is 0, if order is equal to 0, so we can write, what is the concentration term? That is the rate constant K is equal to, what is the concentration term? Mole per liter with respect to time, second, into concentration raised to its power, right? This is rate concentration. This is concentration raised to its power. What is concentration as usual? Mole per liter. Raised to the power 0. Anything to the power of 0 is equal to 1. So this can be written as 1 by 1. So the rate constant, the unit of rate constant is mole per liter per second. Am I right? So this is the unit of rate constant for zero order reaction. Got it? So this is the unit of rate constant for zero order reaction. Let us go for first order reaction. If order is equal to 1, order is equal to 1. So K is equal to, as usual, that is concentration. Mole per liter with respect to time, that is here second, with respect to time into 1 by concentration raised to the power with respect to order. This is a first order reaction. So this is raised to the power of 1. So the same thing will be there. So this one, this term get cancelled. So the unit K is equal to per second, right? The unit of rate constant in case of first order reaction is per second. Got it? Let us go for second order reaction. If order is 2, so K is equal to mole per liter with respect to time into concentration term. Mole per liter raised to its power. What is the power here? What is the power here? 2. What is the power here? 2. So what happens here? This one and this one get cancelled. Got it? So we can write it as mole per mole and liter. Per liter it is also in denominator, so that it can be written as liter. And this is per second, right? So this is the unit of rate constant for second order reaction. So this is a unit of the rate constant for second order reaction. For zero order reaction, what is it? Let me write it here so that to compare the thing, that is this one. For zero order reaction, it is mole per liter per second. Right. For first order reaction, what is it? It is per second. For second order reaction, what is this? Mole per mole liter per second. So this is a way to find out the unit of the rate constant for different order of reaction. Got it? So remember, this is an 1 mark. Important 1 mark. Objective questions. Right? By knowing the unit of the rate constant, we can find out the order of the reaction. If it is per second, we have to understand that this is time inverse. Time inverse in the sense it may be second or minutes or hour. So if it is per second, time inverse, it is nothing but first order reaction. That is mole per liter per second, this is zero order reaction. Per mole liter per second, this is second order reaction. Got it? So these are the units of the rate of the reaction.